Hello there, my name is Cannon, and I am a science and science fiction student here at Eastern Washington University. In this video, I'm going to be going over Boyle's law and the ways that it can be seen and applied to your everyday life. After watching this video, you should be able to calculate changes in pressure when a volume is modified, and vice versa, how much volume would need to be modified to explain a change in pressure. So what is Boyle's law? Boyle's law states that at a constant mass and temperature, the pressure of a gas is inversely proportional to the volume of its particles. In other words, when X number of particles are in a small space, there is a higher pressure than when X number of particles are in a big space. This is commonly depicted in diagrams of pistons, such as this. As you can see, when the volume is smaller, the particles are more condensed, creating larger overall pressure compared to the more voluminous depiction. Mathematically, Boyle's law can be expressed as P is proportional to 1 over V, which is graphed like this. Another associated equation is P1V1 equals P2V2, or the initial pressure times the initial volume is proportionate to the final pressure times the final volume. In order to use this equation, we might assume that we have two closed tanks connected by a blocked pipe, and that the initial pressure in the first tank, which is supposedly 1 liter, is 20 atmospheres. If the pipe is unblocked and air is allowed to flow into the other, say 12-liter tank, what is the final pressure? In this problem, you are given the initial pressure, 20 atmospheres, the initial volume, 1 liter, and the final volume, 13 liters. All that is left to do is solve for the final pressure, and you will find out that there is 1.54 atmospheres of pressure in the combined system. In your everyday life, you're probably not going to be needing a calculator, though, to see Boyle's law in action. Have you ever popped open a bag of fruit snacks or chips? The reason you are able to do this is because when you squeeze the bag, you are decreasing the volume that the air inside takes up, and consequently increasing the pressure. The pressure keeps building up and up and up in this tiny little space until it eventually pops the bag open. Hooray for Boyle's law! Another example might be if you were to poke a hole in a full water bottle. The water would come out at a certain rate, but if you were to increase the pressure on the water by blowing into it on top, then the water would come out of the hole at a much higher rate due to the increase in pressure. So in sum, Boyle's law states that pressure and volume are inversely proportionate to one another. Next time you notice a change in pressure or volume in your day-to-day life, think to yourself, is this a case that can be described by Boyle's law? Thanks for listening, and I hope you learned something new today.